Hello everyone, thank you for joining us and welcome to the Micon Hour. We are a mining consultancy that has provided independent professional advice to mining companies, providers of capital, law firms, and government agencies for over 30 years. Staffed by senior industry consultants with extensive international experience, we are here to discuss relevant topics for the benefit of our mineral industry followers. And now, here is your host, Micon's Mineral Resource Specialist, Alan San Martin.
Hello everyone, I'm Alan San Martin. We are happy to have you here with us today. I'd like to begin with our sustainability statement. At Micon, we work with our clients to promote responsible mining and to integrate the principles of sustainability into their mining projects. In today's episode, we will talk about metallurgical testing in project development. We will discuss this topic, and in this occasion, we will not be opening for questions. However, you can contact us later to follow up or discuss your project with us. We will provide the information at the end of this episode. I'm here today with our co-host and colleague, Nigel Smalley. He's joining us from our Norwich office in the UK. Nigel is the Senior Processing Engineer at Micon. Hello, Nigel. How are you doing today?
I'm good, Alan. How are you?
Yeah, thank you. Thank you for joining us today. So if we can start the conversation, Nigel, let's start with the basics. Why is metallurgy testing important?
Okay. Well, metallurgical testing has a key role in determining the value metal or the mineral recoveries that are important to do a proper economic assessment. But it's also important to generate design, specification and costing information or data to be used for costing the process plant and any subsequent tailings or residue management. So there are many examples of projects that were deemed to be economic at study stage, but then subsequently realized to be less so due to technical problems missed or overlooked as a result of inadequate metallurgical testing. There have also been projects that have been a complete failure because basically the process plant didn't work and the project was subsequently closed. So although fatal technical flaws are less common today, inadequate flow sheet design and incorrect equipment selection can still result in increased OPEX and CAPEX costs, delays in project execution and slower production ramp up. Similarly, incorrect predictions of recovery can have an impact on project revenue as well. So some simple examples of this would be, for instance, incomplete analysis of flotation concentrates that have been generated during test work, which were failed to identify levels of deleterious elements that then go on to incur smelter charges in at a production level. Or another example would be failure to identify ore hardness variability, which leads to potentially incorrect equipment selection and increased operating costs due to wear.
Okay, so that made me think about geometallurgy. So what is the role of geometallurgy in this?
So geometallurgy involves consideration of how related aspects of the project, geology, mineralogy, mining and metallurgy, can interact to maximize the economic return of the project. So a geometallurgical model is used in an extension of the resource model, and it can be used to map metallurgical and mineralogical data in 3D space. So as a simple example of this, the geometallurgical model might identify separate metallurgical domains, for instance, areas of sulfide and oxide minerals that are present in the ore body, and these may require different methods of processing or yield different metal recoveries. So this information can be used to optimize the flotation flow sheet and inform the production schedule going forward.
Okay, so what testing is typically required at the different study stages?
Okay, well, I have prepared a table that identifies the typical stages of study. So from preliminary economic analysis through PFS to feasibility study. So clearly the type of testing required varies depending on the type of target mineral. So you may do different test work for industrial minerals than you would say for metalliferous minerals. But at a scoping level, metallurgical programs are typically carried out to establish how the resource material will respond to commonly used metallurgical processes such as flotation, gravity concentration, or leaching. So the results of those tests would provide indications of recovery that could be used for subsequent economic analysis. At a PFS level, ideally you'd start looking at potential pre-concentration methods. You do further testing to develop preliminary flow sheets, material balances, and some design criteria such as ore hardness, crush and grind sizes, dewatering parameters, look again at overall recoveries and concentrate grades if that's appropriate for, say, for flotation. You'd also ideally look at characterizing the tailings or the residues from any processing to determine what disposal strategy would be appropriate, and also to see what you need to do for environmental compliance. At feasibility level, really that's an extension of the PFS work. So you continue to develop your flow sheets, but do the work in much more depth. So you're producing detailed material balances, detailed process design criteria, which will aid equipment sizing, specification of equipment, and costing. It would also ideally include ore variability testing for your selected flow sheet, comprehensive characterization of your tailings or residues, and effluents, including things like effluent treatment. So, cyanide destruction if you're using cyanide leaching, effluent water treatment. So if you need to make, your discharge, any effluent might have to meet discharge criteria. You do geotechnical and geochemical testing of tailings, say, for instance, for your TSF design. At PFS stage, that might also include doing pilot plant testing if required.
Okay, so now the question is, what are the typical sample sources and the quantities required?
Okay, so typically at PE stage, quantities are probably in the region of 10 to hundreds of kilos, and usually derived from split drill core samples, because that's at the time that would be what was available. At pre-feasibility stage, quantities are more typically perhaps hundreds of kilos, and are usually composite samples produced from dual core samples. At feasibility stage, samples may be in excess of thousands of kilos, and potentially derived from dedicated sample drilling. So you might actually drill holes to actually get bulk samples. They may come from trial pits or underground development work.
Okay, so now we do technical reporting, and one of the most common is 43101 and JORC. So what are the metallurgical testing requirements for these standards?
So in NI 43101, there is as yet no specific requirement. However, following a 2014 update by CIM, there is a requirement by the Canadian exchanges for site-specific metallurgical testing to have been carried out to support resource or reserve definition in a NI 43101 report. This requirement is likely to be specified in the next update of NI 43101, and ultimately to be adopted by other countries or other standards, other reporting standards, because quite often NI 43101 is used as a benchmark.
So in Micon, what is the part that we play in this process?
So we can help to design, cost and supervise metallurgical testing programs at any level of study. So right from it's project inception right through to full feasibility study. We can independently review results from metallurgical test programs that may have been done in studies by third parties. We can also assist selection of appropriate processing methods from metallurgical test results, propose suitable flow sheets, and carry out appropriate cost studies as well.
Okay. Nigel, thank you. I think it's a very interesting topic. So if I can ask you to give us your final comment, what is the one lesson to be taken away today?
From my experience, I would say start the mineralogy and metallurgical testing as early as possible in the project stages, and avoid, if at all possible, taking any shortcuts unless you have a big appetite for risk. So don't jump from a PEA straight to project execution.
All right. Okay, to all our audience, we are now ending this broadcast. Thank you very much for listening, and we will have our contact information so you can follow the conversation.
Thank you for joining us today. We hope you enjoyed this episode. Please feel free to leave your comments or questions, and be sure to follow us on LinkedIn and subscribe to our newsletter so you're kept informed on future episodes.